So here's some more of the particle motion quiz, and we're on letter D now. For what values of t is the object moving left? Explain. Well, we have this nice graph over here we got from our calculator, kind of a realization of what's going on. And we could tell that, I guess write this down like this, letter D. And we would say we're moving left. And we would say t between, let's say pi less than t less than 2 pi. That's the interval that it's moving left. And you could just say the reason would be the velocity of t is less than 0. I guess here or there. So there the velocity is less than 0. So we're moving to the left. So that wasn't too bad. Okay, letter E. Find the total distance traveled by the object over the time interval. So now we have to remember what's the total distance traveled. How do we find that? The total distance traveled. Well, we kind of had a formula for that. The total distance traveled on the interval from A to B was equal to the integral from A to B of the absolute value of the velocity. Because if you're going left or right, the velocity is positive or negative, but you're still moving, so you're still traveling. So we take the absolute value of the velocity. So that's the total distance traveled. You want to remember that formula. It will be on your formula test for sure. So we're going to take, in this case, the integral, and it was from 0 to 8. The absolute value of, we've already got v of t. Remember, this is already in y1. So how could we do that? Well, we could just use Math 9. It's F-N-I and T. That's kind of sloppy like that. And then we're going to take the absolute value, so we would have to do a math number, absolute value, and put y1 in there, comma x, comma 0, comma 8, and that should do it. That should give me the total distance traveled using the absolute value. So we do have that in y1. So let's do that. So on, clear that, and we'll go math 9. And then we want math number. Math number will give us the absolute value, enter. And that puts that right there, and we just put y1, so it's going to be var, y vars, enter, enter. Parentheses for that, and that's our absolute value. That's this part here. And then comma x, that's my variable of integration. And then I'm going from 0 to 8. And that should give me the total distance traveled. Now these are kind of hard to do without a calculator, because then you have to figure out where it's positive, where it's negative, and then flip the negative so you can add up, get all the actual total area. That's a little easier with a graph. Okay, and I got 9.873. Yeah, because that's bigger. 9.873. So that was the total distance traveled. Okay. So these are all basic formulas you need to know. They won't ask you all these questions, but they'll probably ask you 4 or 5 of these, so you want to be able to do all these. And I say, and even dealing with the function without a calculator, so that's where it can get a little tricky. But they sometimes, if they have you to do something like this is so tricky to find out where it's positive and negative, and it takes a lot of time. Sometimes they just ask you to set up the integral but don't evaluate it if it's a non-calculator portion, so be aware of that. Okay, and then F, find the position of the object at t equals 8. So again, At t equals 8, now we're going to look for the position. So I do this all the time, but I guess I can never do it enough. This is f. We know from the fundamental theorem of calculus, if we're dealing with a position function which is s, then we know the integral from, and let's just say for this sake it would be 0 to 8, because that's what they're trying to find. They're trying to find the position at 8. Okay, of s prime of t dt. If we what the antiderivative of s prime is s, so that's just going to be s of 8 minus s of 0, right? Because these are the antiderivatives of the derivative. That makes sense. And we're using the fundamental theorem calculus, the second part. Now what we can do is we can kind of add this to both sides, so we end up with s of 8 equals s of 0 plus the integral from 0 to 8 of s prime of t dt. But remember, s prime is just v of t, and we've already got that. So this is going to be just s of 0. Now, what was my initial position? That was, in this case, it was x of 0, which is 3. So it's going to be 3 plus the integral from 0 to 8 of v of t dt. And this is already in y1, so because the derivative of the position function is the velocity. So I hope you can see how this works. You shouldn't have any trouble remembering this, because I've done this a lot of times. Then we just get this, we just shift this over, we add s to both sides. If we add s of 0, to both sides, we've got s of 8 equals s of 0 over here plus this. But this is a derivative of this. But this is also the derivative of that. So we could just do this with our calculator. We could just say 3 plus fn int, and then we got var y vars, comma x, comma 0, comma 8, and that should give it to us. That would give us our position. Okay, so this is like our initial position and our displacement. So let's do this. We'll go math 9. Well, let's go back. Let's clear that. And let's just go to 3 plus, so 3 plus math 9. And then we'll go var y vars, enter, comma x, comma 0, comma 8 parentheses. So you can do that pretty fast. And we'll get the position, which is 4.213. And that's the position at x equals 8. So if you want to describe the motion, you can say we start over here at 3, and we go to the right, then we go to the left, and then we're going to go to the right. And we end up over here at 4.213. All right, so we start at 3. We go to the right a little bit. We stop at pi, which is 3.14. We don't go very far. Then we go to the left. Well, no, that's not the position, that's the time. So we go to the right. I don't know exactly what the position is. I could find it because we stop at pi. Then I go to the left. And when t is 2 pi, I stop. And I don't know where I stop, just someplace I could find that out also. And then I go to the right, and I end up stopping over here at, this is the position, down here, 4.213. Okay? I don't know where these other stop points are because I'd have to do this, find the position using pi and 2 pi. And I can find the actual positions by putting those in. Okay? So hope that helps.